Welcome back to our live training session. We're going to be taking a look in this tutorial at dialing in our full throttle tuning on our low cam operation. So this is going to be non-VTEC, taking a look at dialing in our airflow model, fueling model, so the VE table, dialing in our spark timing, setting up our knock control, setting up and tuning our variable valve timing control. So we have a lot of things to unpack and discuss in this training module. The first thing I want to jump into here in this training module is going to be setting up our O2 transport delay table. Now in that last training tutorial, I went through the entire part throttle tuning process. We worked with the closed loop correction. We were fine, everything was working correctly. The short-term adjustment was doing exactly what it should. The response of the closed loop system seemed appropriate. The only thing that I did not touch on and change from the base file from Emtron was the O2 transport delay. Now that's very specific for the engine and the O2 location that we're dealing with here. The O2 transport delay is measuring the amount of time it takes for the difference movement between when we command a certain lambda and we move to a different command at lambda. So that's very specific. We need to take a look at a data log that's going to essentially encompass this in order to figure out how to go in and set up our O2 transport delay table. Setting up the O2 transport delay table improves our closed loop fuel control, so we definitely want to do this step whenever possible. So let's go and look at this real quick. So under our engine functions, under lambda control wideband, we have our lambda transport delay. Now this table is set up on engine speed versus efficiency calculation. We can greatly simplify this table, turn it into a two-dimensional table, and set this up on air mass final flow, grams per second. That allows us to dial in specific table values, and just doing that over a larger range of operation. We do not need a three-dimensional table. It's definitely difficult to get everything worked out for a three-dimensional table here. So let's click A, and we're gonna get rid of our y-axis, which is the efficiency calculation. We'll go to our x-axis, and we're gonna change this, and we type in here air mass. Let's see what it comes up with for options. We're looking for air mass final flow, air mass flow final, and that's going to be grams per second. Now we can clear it out and we can move in increments of something like 20 should be sufficient, and that should be good here. Let's just populate this out, say yes. So now all the values in the table are the same, which is not going to be ideal. What we need to do is take a look at the data from a log in order to figure out how to go about populating our transport delay table. Now, it's actually quite simple, and what I've done off camera before I started to film here is simply drive the vehicle here on the mainline dyno, and I was able to go in and just vary the lambda target. So I was just driving, change the lambda target, so I went into the lambda target table here, and I changed from, let's say, 1.0 lambda to 0.9 lambda. Then I flipped it back to 1.0 lambda and went to different driving ranges, different throttle ranges, essentially going through various different airflow ranges to be able to dial in and populate our table out. So let's jump back into our O2 transport delay, and let's go over here into our delay table here, and let's look at our data log. So what we can find is this is the log file, and what we're looking for specifically is we have our lambda and our target. And what we're looking for is when we command the lambda to move, how long does that, the target to move, how long does the actual lambda take to start to change its position and movement? Now I went a couple different RPM ranges, a couple different throttle ranges, trying to kind of go through the various airflow ranges that we would find within a table as we're trying to populate. So looking at this, what we need to do here is zoom in. I'm going to use my up arrow, and what we're going to look for is when we see our lambda, so again I was changing it from, let's say, 1.0 lambda to 0.9 lambda, when we see our lambda change to how long, so we see the white mark, that's our target lambda, so we see that change to how long it actually moves, so how long it takes for the actual lambda sensor to actually start to drop down and move towards the target that we're requesting. So looking at this, we need to use a specific function here that's going to show us a time constant, or a time that we need to populate to our O2 transport delay table. If we use the D button, that's going to allow us to go in here and start to measure between 2 points. We want to measure from the point where we have our lambda sensor here going from, let's 1200 RPM, so we see at 1.0 lambda, it switches over to 0.9 lambda, and we want to measure the point where the pink, that's our actual lambda measurement, it's going to go from 1.0 lambda and then start to move down to the richer target. So if we go and click in here, oh, we might have went in there and deselect that. Let's actually go back in here and we can pick that log file back up here. Let's select that log. Actually, that might be our other log file here. There we go. Now we're back in there. Okay. Let's go focus back in here. So we're going to use our D function, which is going to allow us to give us that time lapse, or the time between these 2 points. So if I use my D button, that's going to start to take a measurement. Now I want to use the B button to put both of my points of reference here together, and then I can just slide them apart. Now notice I have a dotted line. That's where I'm starting my count from. That's going to be here at that white line, and then where it goes and it starts to drop down. We're measuring here from the pink to where it actually starts to move, which is right about here. So we're seeing this is about a 0.597 second value that we need to populate at a certain airflow range. And this is at idle conditions. Let's see what this looks like. Let's flip back into our table, and that's gonna be here between.
Thanks for checking out our teaser clip. If you wanna see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you wanna go and check out more teaser clips from this training course, click here, and you don't wanna miss any of the videos we're gonna be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.